A student has a 0.667 litre sample of a solution of lithium chloride, LiCl, with unknown molarity. She tests several different samples of lithium chloride solution of known molarity in a spectrophotometer to produce the absorbance molarity graph provided. That's this graph here, absorbance and molarity. She then tests the unknown solution in the spectrophotometer and gets an absorbance of 0.400. This image up here shows a spectrophotometer. The way it works is that it shines a certain brightness of light at a sample of a fluid. Some of that light is absorbed by the fluid. The detector measures how much of the initial light brightness was absorbed. And if you have a stronger concentration of a solution, it's going to absorb more light. If you have a weaker concentration or molarity, it's going to absorb less light. So that's why if we look at our graph down here, as the molarity or concentration of the solution increases, the absorbance also increases. So we're going to be using this graph to figure out the molarity of our solution. So we're told that our unknown solution has an absorbance of 0.400. So if we look on our y-axis, our absorbance is 0.4 for the unknown solution. So if we follow along to see where that hits our graph, and then we follow down, we'll see that an absorbance of 0.4 corresponds to a molarity of 0.8. So based on our sample solutions that the student used to make this graph, we know that our unknown solution matches up with the one that has an absorbance of 0.4, which means it must have a molarity of 0.8. So that's how we're going to use this absorbance molarity graph to figure out the molarity of our unknown solution. So 0.8 is our molarity. Then we can go ahead and fill out our table here with our known variables. So we know the molarity is 0.8 m, because we just calculated that. And then back in the question, we were told it was a 0.667 litre sample. So that's our volume, 0.667 litres. And we're trying to figure out the number of moles. So let's head again to our reference sheet. Here's our molarity equation again at the top. M equals N divided by V. So let's write that down. M equals N divided by V. We're trying to find N, the number of moles. So we're going to have to rearrange this equation. Right now, N is divided by V. So we're going to multiply by V on both sides and cancel the V's, which leaves us with N equals V times M. So we can go ahead and put in our numbers there. V is the volume, which is 0.667, multiplied by M, the molarity, which was 0.8. So that gives us a number of moles, when we multiply that out, of 0.534 moles. So let's go ahead and check if we got that correct over here. Awesome. And that's going to be our final answer. How many moles of lithium chloride were in the sample? 0.534 moles. So again, this question is very similar to the previous two. We're using the exact same equation for molarity, exact same setup. The only difference here is that we're using our absorbance molarity graph from the spectrophotometer in order to figure out the molarity of our sample.